Welcome back. In this section, we will learn solve system of linear equations. So specifically, we will first look at how we determine if an ordered pair is a solution to a given system of linear equations. Then we will talk about graphing methods, solving a system of linear equations. Then I will talk about substitution method. Then we'll talk about addition method. Then we will talk about some applications. Okay, so most of the methods you already have seen them in the high school, but here we will systematically look at them, and maybe it's a review for many of you. All right, so let's look at how we decide if a given pair is a solution to a given equation. So for example, let's say given a linear system, x plus 2y equals to 12, 2x minus y equals to -1. So we want to ask is, let's say, this order pair 0, 6 a solution? Of course, the solution is set with respect to the given system. So what we do, how we solve this, well, how we answer this question? Well, very simple. All we need is substitute. So here is the solution, right? Substitute x equal to 0. By the way, order pair means that first number is a x coordinate and the second number is a y coordinate. So substitute x equals 0, y equal to 6 into the system, okay? Into the system. And what we need is check if the given pair satisfy each equation. Okay, so that's what we need to do. So let's see first equation. Let's see first equation. Let's check if the first equation is satisfied by the given ordered pair. So first equation is x plus 2y on the left hand side. So let's plug in x equals 0 and y equals to 6. Now 2y means 2 times 6. So obviously it's 12 and the first equation is satisfied. So let's check the second equation, right? So the first equation is okay. So let's check that. Second equation, 2x minus y, the left-hand side of the second equation, and plug in x equals 0, so 2 times 0 minus y equal to 6, or is 0 minus 6 is -6, which is not equal to -1. So the second equation is not satisfied, not satisfied. Therefore, so we conclude, therefore, 0, 6 is not a solution to the given system. So fairly simple. Next, let's talk about how to use a graphing method to solve a system linear equations. So given a system linear equations, let's say a lot of time we use our brace to group the two equations. Let's say suppose we are given the system ax plus bx equals to c. Okay, so this is our first equation. By the way, to indicate this is first equation, I'm going to use subscript 1 to indicate those are the coefficients for the first equation. Similarly, we have a2x plus b2y equals to c2. So by the way, the first should be x. I should change that, x to y. So b1y equal to c1. Okay, so this is first equation. Of course, we know the graph of each, because each equation is a linear equation. So the graph of each equation is a line, straight line, right? So 9, 1, and this is 9, 2. Okay, so or actually, let me change the notation of 9, 1 using blue. So I'm gonna erase equation 1. I'm gonna use blue to be consistent with the graph. So a1x plus b1y equals to c1, and this is 9, 1. Okay, now if you suppose you want to plot both lines in the xy plane, right? Think about how many possible cases can you have in terms of the mutual positions of 9, 1 and 9, 2. Obviously, there are only 3 possible cases. Number 1, the 2 lines intersect at one point. Okay, so in this case, the intersection point is the unique solution. Okay, when 2 lines intersect, meaning that there is a common point, or the common point is on both lines, meaning that the coordinates of the common point satisfy both equations. So therefore, it is the only solution to the linear system. The second case you can think about is, what if 9, 1, 9, 2 are parallel but not coincident? In this case, you would be looking at the second case, right? The 9, 1, 9, 2 have the same slope. In this case, same slope, but different y-intercept, right? Because they do not coincide. So therefore, in this case, because the 2 lines do not intersect, you cannot find a common point on both lines. Therefore, there is no solution to the system, and the system is called inconsistent. Inconsistent. By the way, the first case, the system is called consistent. What if the 2 lines actually coincide? So that will be the third case. In this case, that the 2 lines coincide. 2 lines coincide, right? So you actually have, so 9, 1 overlaps with 9, 2. You usually only see 1 line. In this case, that obviously that every point on the line is a solution to the system. So the system itself has infinitely many number of solutions. The system is said to be dependent. So first equation is dependent on the second equation, or you can see the second equation is dependent on the first equation. A quick example for this might be a little bit strange, but a quick example would be, let's see, x plus 2y equals to 1. And second equation, let's say, is just 2x plus 4y equals to 2. So you can see that second equation really is obtained by multiplying the first equation by 2. But, you can, if you divide the second equation by 2, you get an equation identical to the first equation. So therefore, the system, although appears as having two equations, really only has one equation, but with two variables. In this case, you end up with an infinite many number of solutions to the system. All right. So let's see. Let's look at an example, right? Let's look at an example here. Let's see. Suppose we have a system given by x plus y equals to 4 and 2x minus y equals to negative 1. Let's try to solve it by graphing both lines, right? So I will name the first equation by equation 1 and second equation by equation 2. Okay? So I will do it first. I'm going to plot x plus 4 equals to 4. X plus y equals to 4. That's my first step. Now my second step would be plot the second equation, 2x minus y equals to negative 1. Okay, so and then I will say if I have the first case when the two lines intersect, or I have the second case when the two lines parallel but do not coincide, or the two lines actually becomes one line, right? So there are only three cases. So how to plot the first line? If you recall, what we can do is we got x plus y equal to 4. We can find 2 points on the line, or we can use the x-intercept, y-intercept, and then we can plot the line, right? So now this first equation is simple. We can actually do two lines. So let's just find 2 points. Right? So what we can do is we can let x equal 0. So this is equivalent to find the y-intercept. So x equals 0 if you plug in y just equal to 4. This gives me 0, 4, right? Secondly, I'm gonna let y equal 0, so equivalent to find x-intercept. So this gives me immediately x equal to 4. So this is 4, 0. So let's plot the x-axis, y-axis, okay, x, y, 1, 2, 3, 4. That's 4. So, and 1, 2, 3, 4. Right. I'm gonna change the color to red. So because it passes through those 2 points. So 4, 0 and 0, 4. So here is the line. Right? So that's the first line. Now let me, using the same method to plot the second line, I will still find 2 points. So first I let x equal 0. Obviously I get negative y equals to negative 1, which means y equals to 1. So this gives me the point 0, 1, right? And then I set y equal to 0, then I get 2x equals to negative 1, which means x equal to negative half. So this gives me negative half, 0, the second point, right? So I set x equals 0, set y equals 0, and set. So let's plot those 2 points. 0, 1, 0, 1 would be this point. Negative half, 0. Okay, negative half, 0 would be this point, right? So because here is negative 1. So the 2 lines, or this is the second line, and this is the first line. The 2 lines actually intersects right here, which is around 2, 2, something like that. But we can use algebraic method to find the exact solution. But the point is, yes, there is a unique solution. Okay. Now let's discuss the substitution method, which is the algebraic method that allows us to find exact solution. Okay. So let's look at this example here. I'm going to just change it to red. Okay, so let's see. We got an example here. Example, I want to solve the system x plus y equals to 4 and 2x minus y equals to negative 1. So we want to solve this by substitution method. Okay, again, equation 1, equation 2. So what are the general steps? Well, it's fairly simple. First, select an equation and solve it for one variable, meaning either x or y. So since you can select any equation, so typically select the equation and the variable so that it is easy to solve for that variable. Okay, so example here, if we select equation 1, we can easily solve for either x or y. The idea is that the coefficient of x or y is 1, so we can easily solve for either x or 1. So let's see, we're going to select from equation 1, we have x plus y equal to 4. So we can just solve it for either x or y, it doesn't matter. So let's just solve it for x. Okay. So from that, if we solve for x, we just subtract y from both sides, we get x equal to 4 minus y. So this is our third equation. Now, what does this third equation do is it represents x in terms of y. So then, because every x can be represented as 4 minus y, meaning that if substitute equation 3 into 2, meaning replace x by 4 minus y, then you can eliminate y, right? So, or you can eliminate x. So let's see, the second equation is 2x minus y equals to negative 1, okay? And then what we're going to do is we're going to substitute 3 into this equation, 2. Okay, this is equation 2. So x equal to 4 minus 1, then we're going to get, we replace x by 4 minus y. And then minus y equals to negative 1. Now, obviously that this becomes, so we eliminated y, eliminated x, I'm sorry. I eliminated x and obtained an equation just in y. So, and then I can solve it. So I just simplify the left-hand side. I get 8 minus 2y minus y equals to negative 1. And obviously this becomes 8 minus 3y equals to negative 1. Remember, the goal is to separate, in this case, that to solve for y, you need to isolate the terms with y. So it continue becomes negative 3y, subtract 8 from both sides. So I get negative 1 minus 8 is negative 9. And then I divide both sides by negative 3. I get y equal to 3. So this, you see now, we are very close to the final solution because we already found the value of y is equal to 3. And then this is your substitution step, second step. So last step is you plug in y equal to 3, which is what you found, into either equation is fine. Or let's just say into 3. Okay. Into 3. 1 or 2, if you use equation 1 or 2, is also okay. Okay, so that, but because we already represent x in terms of y, and we know the value of y, so in equation 3, so it appears that if we substitute y equals 3 into equation 3, it might be a little bit easier as far as the calculation. So because x equal to 4 minus y, that's equation 3, so equal to 4 minus y is 3, so this gives me 1. So we found x equal to 1 and y equal to 3. So, we can summarize lastly, x, y, the order pair equals to x is 1 and y is 3. And that's the final solution we found for the system linear equations. So this is a general idea of how to use substitution method to solve a system linear equation. Okay, so now let's look at an example of how to use addition method to solve a system of linear equations. Okay, so let's look at this example here. Example, we want to solve 4x plus y equal to 13 and 2x, let's see, minus 2y equals to 1. Okay, again, I'm gonna name this equation to be equation 1. I'm gonna name this equation to be 2. Okay, so what's the general idea? The general idea here is general idea of addition method. The general idea is that you're gonna multiply or divide either equation or both by some constant. Okay, and we will talk about the choice. How do you choose a constant to multiply or divide? Okay, now how to choose those constants? So you choose those constants so that when ending the equations, after you multiplying or dividing the original equations, the sum will be an equation containing only one variable. So in other words, the key idea is to eliminate one variable. Okay, so either substitution method or the addition method, the key idea is you want to eliminate one variable. Okay, so here, I do a little bit of more observation here. I notice that the coefficient of equation 1 is 4 and coefficient of equation 2 is 2. So example here. So for instance, if I observe the coefficient of equation 1 is 4, coefficient of x of equation 2 is 2. So if I multiply -1 to equation 1 and then add it to 2 multiplied to equation 2, this will allow me to eliminate x. Okay, so that's one way to do it. Another way to do it is a lot of time we choose the variable that have opposite sign of coefficient. So here the variable y is such an example because the coefficient of y in equation 1 is 1 and coefficient of y in equation 2 is -2. So therefore, if I multiply equation 1 by 2, right, and then add it to equation 1 multiplied by equation 2, basically you don't need to do anything to equation 2, and this will allow you to eliminate eliminate variable y. Okay, so either way works. So let's try both. Okay, once you get familiar with it, you just choose the one that is the easiest one, the one that is easier to solve the system. Okay, so let's first try this one because it appears a little bit easier. So I'm gonna need to multiply equation 1 by 2. So equation 1 multiplied by 2 would be 2 times 4x plus y equals to 13. So basically you do that. Well, if you do that, you get 2 times 4x, 8x plus 2y equals to 26. And then equation 2 multiplied by 1 is just the equation 2 itself, so you just copy it. You have 2x minus 2y equals to 1. Now you see if you add them up, okay, add them up. So you add them up. So you get 8x plus 2x, that's 10x, and 2y minus 2y, that's 0, and equals to 27. And this gives you x equal to 27 divided by 10, right? 2.7. So you see, it gives you an easy answer for x. And now, with x equals 7, what you do is you put, let's say x equal to 2.7 in, you can put it in equation 1 or 2, it doesn't matter. So let's just put it in 2, because it appears a little bit easier to solve for x, because I got a coefficient of 2 for x in equation 2. So I have 2x minus 2, or x is already known, so I actually need to plug in the number 2.7 for x. So I'm gonna erase that. Let me use, okay. So I would have 2x with 2 times 2.7 and minus 2y equals to 1. Well, this gives me 2 times 2.7 is 5.4 minus 2y equals to 1. Again, separate variable, you get minus 2y equals to, you're going to subtract 5.4 from both sides. So 1 minus 5.4 is negative 4.4. This gives you y equals to 2.2. So the solution for y is that, solution for x is 2.7. So that would be a solution. Okay? So you can use a similar idea, and using the first approach also should find the same solution as well. So let's try that quickly. So let me change the color to blue. So I'm gonna multiply the first equation by -1 and the second equation by 2 and then add them up. So the first equation multiplied by -1, meaning basically you change the sign of every term. So that's minus 4x minus y equals to minus 13, right? Then you multiply the second equation by 2, okay? Again, the design that after you multiplying and a constant to each equation, you sum them up, you are able to eliminate one variable. So 2 times 2x is 4x minus, you multiply every term by 2, minus 4y, because 2y minus 2y times 2 is 4y equals to 2, right? And then you sum them up. Notice minus 4x plus 4x is 0, minus 1 minus 5, 4y is minus 5y, and minus 13 plus 2 is minus 11, and this gives you y equal to 11 over 2, which is 2.2. Should be the same. Okay, great. See, y equal to 2.2. And then next is you substitute y equals to 2.2. Let's say we want to into equation 2. Again, the idea is it's going to be you choose the equations so that it's easier for you to solve for x, right? So 2x minus 2 times y now is 2.2. Okay, so to make it clear, I'm going to insert parentheses just to indicate the multiplication. So equals to 1. And so if I simplify the left-hand side, 2 times 2.2 is 4.4 equals to 1. And then I'm going to move 4 and 4.4 on both sides to get 5.4. And again, divide both sides by 2, I get x equal to 2.7. The same, exactly the same solution by using a slightly different approach. So you see, either way it works. So those are the addition method or substitution method. The key idea to eliminate one variable.